In this tutorial, we'll be discussing cycloalkanes. We've already discussed some of our straight chain compounds, but cycloalkanes are ring structures. We should note here that all of the bonds in our cycloalkanes are going to be sp3 bonds, and we know that sp3 bonds should be at 109.5 degrees, but they all are not. If we look at our three-membered structure here, this is the most unstable. We see that it's very strained. If we look at the bonds here, they look like they're kind of strained, and so this is 60 degrees here, and it's not 109.5. If we take a look at our bonds here in line, we see that all of these atoms are completely eclipsed each way that we turn this. And we also have steric hindrance here at the top with all these atoms here and the ones at the bottom. Another thing to note is that we can have cis-trans isomers. If we take a look at this molecule in this plane here, we see that these two groups on the top that are red are cis to each other, and we can also have trans. If I were to change these here, this would be our trans isomer. An important thing to note is that these are not interchangeable, that these are two separate substances. And if these were all hydrogens, we would not have any cis-trans isomers, but it becomes important when we have different groups here. The next cycloalkane that we'll be examining is called cyclobutane, and it's our four-membered structure here. We see that this is a little less strained than our cyclopropane, but it's also somewhat unstable. Here the bond angles are 90 degrees, and if this molecule is completely planar, if we look down this line here, we see that each of these atoms are completely eclipsed. However, unlike cyclopropane, cyclobutane has the ability to relieve some of the strain by puckering a little bit. If we see here, if we move this up, that this is no longer eclipsed, now it's slightly staggered. This relieves some of our strain on the molecule. We can also take a look at our cis-trans here again. We see that these two groups on top are the red groups. If they are on the same side, then they're cis to each other. And if we happen to move this to the bottom, this would be our trans isomer. And once again, it's important to note that these are not interchangeable, that these are two different substances. The last cycloalkane that we'll be looking at is cyclopentane, and it's our five-membered ring. Here, the bond angles are 108 degrees, which is pretty close to 109.5, so as you could probably tell, this is more stable than the last two that we've looked at. We can also take a look here at our bonds. If this is completely planar, we see that these are all eclipsed bonds on each side. And cyclopentane has even more ability to be able to relieve some of the angle strain by making what we call the envelope structure. So if we move this bond up, we see that this is actually pretty staggered in comparison to the ones before that were eclipsed. So this relieves some of the strain and some of the steric hindrance that we have on the molecule. And once again, we'll take a look at our cis-trans. We see here that these two groups on the top, the blue groups, are, according to the plane, that they're both on top. That means they're cis to each other. If we're to change this down, we see now that the one is on top and one's on bottom, so this would be our trans isomer. Again, it's important to note that if these were all hydrogens, we wouldn't have any cis-trans isomers, but we would need to have different groups here, and that will be important later as you move on.